In Dev Team, today we are going to be talking about creating cliff faces with design using PCG. So the way that we need to think about this, first and foremost, is that this is a playable space. This is an area that the player is able to navigate, and therefore we need to be thinking about how they're going to navigate it. So when we think about that, we can't use random scattering, especially not at this scale with such complex collision. And therefore, we need to go about designing it in a slightly different way. Now, the easiest way to go about doing this is by using level instances. So the power of level instances means that we can design a space and then we can reuse that space in lots of different areas. Now, for this particular example, I have created a level instance and I have spawned it along a series of splines. So you can see I've created a few different PCGs that kind of all use the same base, and they just spawn this one level instance. Now, in an ideal world, we'd have far more than one level instance for this kind of rock wall. For something of this particular size and this particular size, we'd want at least four, to kind of give ourselves enough variation. For anything larger than that, we would be needing to go, for anything like this, or even this, we would want, kind of 10, 20 different variants that we could use. But for this particular example, we've just got the one to work with. So the way that this works is very simple. We have our spline element here, which is sampled by the PCG. The PCG then generates some point data for that, and then we copy this particular level instance, so cliff example PCG, across all of those points. We then filter it, which again is one of the real powerhouses or power use cases of PCG, is that we can then filter and modify data after the fact. So we can basically filter out data that we don't need anymore, so removing points. We can use it to generate random variation between all the points that we've generated, and we can modify those points as well. So that's all I've done here to create this cliff top. And what that means is that because we're working with a designed base, so because we're using that level instance where we've designed a play space, rather than using random scattering, it's much easier for us to create actual playable areas inside our cliff top. So if we go into the game here, you can see that I have all of these areas that we can kind of jump around and explore. There's lots of kind of navigable camera space for me to run around, and I can go in and I can very easily hop up to the next level and kind of jump around these different areas to get to different spaces. So we've got all of these different areas, and as I go up, I can get up again. Let's hop up to the top space. And you can see that I've got kind of the top area here, the kind of finishing my cliff top. So the way that we go about designing this is again very easy. We just do it inside a level instance. So if we go into one here, and generally I will keep my play space, so the area that I'm designing, at the pivot center. So you can see that that's my pivot point here, and this top area is the kind of the playable space that I want to be able to navigate. So all I need to do here is go in and kind of design that playable area. So kind of create some nice verticality, a little bit of height variation, things like that, and then I can set dress it with all of the different elements that we've got inside our Titan project. So I've done all of that here, and then all we need to do is extend down for quite a significant amount. So you can see that that's my player there. We extend down a good couple of meters with duplicate rock assets. Now, ideally for this kind of asset, we would want to have some larger, smoother faces in here. We didn't actually have any of those in the project that I could find at the time, so we're just kind of working with what we've got. But basically we want to create some nice kind of like large rock shapes that we can use to kind of bulk out our cliff top. So once we've got that, we can then tag the geometry, which is going to allow us to create some more random variation. So all of these shrubs and bushes, if we type in tag, you can see that they've got a tag value called random cull. And basically this just allows me to really easily assign, kind of groups to PCG. So PCG will pick up on all of these tags, and I can then use that to filter them later on. So I can use all of the items that are marked as random cull to basically say, any of these items that are currently here, I don't mind if you get rid of them. And that way we can create lots of random variations. So, when we're spawning these over and over again, we're not seeing the exact same, triangle of shrub every single time. We're seeing it, kind of different variances. And the more variants we put in here, the more variation we're going to get later on. And finally, we can do other stuff as well. So you can set modifiers as well. That's again just with tags. So this tree has a zup value that I've tagged it. Again, all the names are completely arbitrary. We just specify what name we want to use when we actually get to the PCG. And this is tagged with zup, basically saying I want this to always spawn vertically. I want it to, no matter the orientation of this particular thing, I want you to spawn up. And then once we've got that, what we need to do is right click on our level. So I'm working inside this level because it's got my lighting, but my actual level is sitting here as a level instance, li cliff example. Go to asset actions and then create PCG asset from level. That's going to create this data asset here, which basically is just storing all of that information as point data. And then if we go back into Titan main, you can see that rock data being pulled in here. So all I've done then is created an actor with a spline component and the PCG component, which we're kind of marking out our point data here. And then all we do is we get those points along the spline and then copy points, which is basically all of the rock points and trees and shrubs and all of that information is just coming out here, and we copy it across that spline. So that's now copying across here, and that just means that we can take that and we can really kind of like exaggerate it and move it however we want across this shape, and it gives us a really nice control path for this particular asset. And then we can go in and we can start tweaking and modifying it. So for this one, I've created a custom blueprint that basically compares these 2 points together. So the first one is the original data set. The second one is the data set projected to the landscape. And then we just compare the height of those two things, and we can use that to determine whether the asset is below the landscape or not. And if it is, then we cull it. So if we go into just below our landscape, you can see we've got some of our points visible here. If we go in and we filter that, you can see a lot more are visible, and that's just because we're going in and we're culling all of that data. So this is a really good use case of PCG. We're using it to strip out all of the information that we know is not there, and there's loads more that you can do with that as well. You can go in and detect whether points are sat inside other points, or kind of they're not visible, and loads of different things to kind of filter that data out. So we can do that. We can also then modify it again based on those tags. So here we just have an attribute filter here, which is detecting random cull. And then anything inside that filter, so anything marked as random cull, we add an attribute noise to, and then filter out that noise based on an exposed value. So the exposed value is really easy to create. We just go to the instance parameters here, press add, name it, and then you just add it in to the parameter there. So this is just changing this upper bounds parameter to be an exposed value. So we can now change this for each of our elements. So let's say this middle path, we don't want it to cull any of those points at all. All we need to do is go in, find our exposed points, which I should be able to do if I get this one, parameter overrides, set this back up to 1, now you can see that every single one of those is spawning a tree, which obviously we don't necessarily want. So we can go in and we can kind of filter that back out to get something a bit more natural. So we then take our points, and again we just combine them back in together again. We then check for the Z-up filter and do a transform to basically lock the tree to have the correct rotation on it, and then combine those back in and then output the static mesh spawner. One thing to keep in mind if you're using static mesh with the copy points from a level instance, you don't need to specify the static mesh because it's already done, but you do need to specify that it's selector by attribute, and then specify attribute name as mesh. And then if you want to override the materials from their default, then you'll also need to tell it to use the material as well. And then you still need to go in and make sure that these are all marked as static. Now, what you might also need to do is go in and do multiple static meshes based on an attribute filter that says what type of static mesh we want it to be. So if we had, let's say, for instance, we want some to have collision and others to collide, then we might create a tag called collide. And then any of these actors that are within that, so they do have collision, we'd want to tell them to block all. And then all of the ones that don't, we would want to say as having no collision. Same with kind of any of the other properties, whether we want them to inject into an RVT, for example, or anything like that. We could then split using this technique here. And then that's pretty much it. So that gives us a really nice kind of playable space. It's very, very quick, very easy to do, and is well worth kind of adding in. Again, this is not the only way of doing this. There's lots of different ways of designing cliff faces. You have to design them differently based on the type of cliff you want to make. So if you want the cliff top to be accessible or inaccessible, you would design this in a different way. And again, depending on the type of rock that you're using, you might go about designing this differently as well. So there's lots and lots of different ways to do it, but you should go in, experiment, and just always consider how you can design the space. Once you get to non-collidable, something that's not going to interfere with player navigation, so things like these little pebbles on the ground that we've got here, they are fine to just spawn and scatter. That's a prime example. Like another one would be as if I wanted to have grass spawning on top of this. I could create again, projection on top of this and scatter grass on top of it. I don't need to go in and design that grass, because I know that it's never going to collide with the player. It's not going to be have as much of a design implication. But whenever we have collidables, anything that the player can interact with, anything that the player would expect to be able to navigate or walk on, we have to go in and we have to add a design layer on top of it. Hope that helps. Feel free to ask more questions in the Discord.